Today we're going to start looking at section 4.1, which is all about exponential functions. So today our objectives are we're going to evaluate exponential functions, we're going to graph exponential functions, and we're going to evaluate functions with a base of e. Exponential functions. Let's talk about what that is. These are functions whose equations contain a variable in the exponent. Okay, so exponential functions, functions whose equations contain a variable in the exponent. Many real-life situations, including population growth, growth of epidemics, talking about radioactive decay, other changes that involve rapid increasing or decreasing, those are usually described using these exponential functions. So, what's the definition of an exponential function? Well, the exponential function f with base b is defined by f of x equals b to the power of x or y equals b to the power of x. So f of x is in function notation, y equals isn't. But notice how they both equal b to the power of x. B is a positive constant other than 1. So that means that's greater than 0, but once again, not 1. And x can be any real number. So positive, negative, a fraction, whole number, anything along those lines. So here are some examples of exponential functions. We got f of x equals 8 to the power of x, and we've got g of x equals 1/2, all raised to the x minus 3. I just want to point out vocabulary is going to be important. So notice that the exponents are obviously what the term's being raised to, but those 8 and 1/2 are what we call the bases. Okay, so bases can be whole numbers, they can be fractions. Okay, so those are exponential functions. All right, so you're going to need at least a scientific calculator, if not a graphing calculator. We just want to approximate each number using a calculator. It says we're going to round our answer to 3 decimal places. So just remember, when you're using a scientific calculator or even a graphing calculator, you're going to hit the base first. So number 1, it's 7. So you're going to hit 7, and then you want to find that little caret button. So looks like that. So that would take you to then an exponent, and then you can type in whatever the number is. So in this case, it's the negative 1.2. Once again, they want us then to round to 3 decimal places. So notice that rounding very carefully, we should get 0.097. Okay, so notice that because it said 0.0968015559, remember, if I want 3 decimal places, I look at the 4th decimal. That tells me whether or not the 3rd decimal stays as it is or rounds up. Because that 4th decimal was an 8, I know that that means I round that 3rd number up. So that's why it became the 7. And so there's my answer. All right, same idea. Notice that we'll put our base of of 6 first. We'll hit our little caret to get to an exponent term, and then we'll take the square root of 2 as the exponent. So once again, then approximating this to 3 decimal places, we should hopefully be getting 12.603. Now, if you aren't getting these for some reason, please reach out to me. We're going to want to make sure that you're okay using the calculator. Okay, and then you've got this last one. We've got e raised to the 5.7. Now, e is actually a number, and this is something that I'll go more in depth with in a later lesson. But you're going to be able to find that number e on your calculator. So if you're looking at your calculator, hopefully you notice that you've got, your original buttons, and then you could hit second, and then you can hit a bunch of the same buttons, but it'll be whatever the thing is up at the top. So depending on like what kind of calculator you have, your second button might be green, your second button might be blue, but regardless, you should find that little e to the power of x term that is associated with the ln button. So if you find the ln button, you'll see that right above it, you'll see an e to the power of x term. So what you're going to have to do is you're going to have to first hit the second button, then you'll hit ln, because that will then take you to the base of e. And then right away, your calculator should have it in an exponent form where then you can now just type the exponent. So then you can just type 5.7. So once again, if you're unsure of where that E button is, please reach out to me and I can show you on Zoom or something along those lines. Okay, so once again, I want to approximate this. So 3 decimal places, we should have gotten 298.867. Okay, because part of your homework is going to be you looking at numbers and approximating them with your calculator. So if you have any questions on how to use your calculator, please let me know. All right, let's talk about graphing exponential functions. So let's just first look at the function f of x equals 2 to the power of x. What are we going to do? In order to graph, we're going to make a table of values, just like we've done back first semester in like chapter 1 when we were thinking about like the point plotting. Okay, remember x, that exponent can be any real number. It can be negatives, it can be positive, it can be 0. But we're going to make a table of values. Okay, so here would be a table if I went from -3 to +3. So notice that we have 2 to the -3rd power, that becomes 1/8. 2 to the -2nd power is 1/4, and so on and so forth. Okay, so you'd make your table. We are going to have horizontal asymptotes in this graph. Okay, remember we talked about horizontal asymptotes back in chapter 3. Those are going to be horizontal lines, and the graph is never going to touch or cross this line. Okay, so based off of the table, hopefully you notice that as you're getting to more negative numbers, you're getting smaller and smaller and smaller fractions, but there's not going to be a way for us to get to 0. So that's actually, in this particular example, going to be the horizontal asymptote. So notice that here's my graph, horizontal asymptote y equals 0. So my graph on the left is getting closer and closer and closer to that x-axis without actually touching or crossing it. And then we are also going to be stating domain and range. So remember, domain deals with the x values. Well, kind of like our quadratics, when we're talking about domain, there's going to be all real numbers here. I can plug in negative, 0, positive. So that's why my domain is going to go from -infinity to +infinity. It's the range that's going to be affected because wherever my horizontal asymptote starts, that's going to be then where my range is going to start. But once again, it's not going to include that number. So if you notice that in this particular example, the range goes from 0 to infinity, but your parentheses around both of them because it doesn't actually hit 0. It's the next number right next to 0. So, 0.000000001. Okay, so something super close to 0, but not actually 0. All right, so let's take those steps and let's actually graph. So we're going to graph making a table. We're going to state the horizontal asymptote as well as the domain and the range. All right, so we are going to graph f of x equals 1/3 raised to the power of x. Now, in the last example, we went from -3 to +3. I'm okay if we don't do that many numbers. I think I'm going to make a table and I'm going to go from -2 to +2. So I'm going to cut it down by a couple of numbers here. Okay, so -2, -1, 0, 1, and 2. So I'm going to plug in. Notice how there's parentheses around the 1/3. So if you're typing it into your calculator, make sure you have those parentheses. We want to make sure that both the 1 and the 3 is being raised to that exponent. Okay, so here's my table with what I'm going to be substituting. So 1/3 raised to the -2nd power, hopefully we're getting 9. 1/3 raised to the -1st power will be 3. Anything raised to the power of 0 is 1. Obviously, 1/3 to the 1st power is a third, and 1/3 squared would be 1/9. Okay, so notice that we're starting with -2 up at 9, plot my point. We've got -1 at 3, got 0, 1. Then notice how 1/3, it's getting closer to 0, then 2 1/9, getting even closer to 0. So notice that if I then connect my points, we got this curve and it is going to be getting closer and closer and closer to 0. So as far as stating then our horizontal asymptote, it will be that y equals 0. So it's never going to touch, it's never going to cross. It's getting closer and closer and closer to 0, because as we keep, in this case, getting bigger and bigger exponents, our fractions just keep getting smaller and smaller and smaller. Okay, as far as our domain goes, remember we plugged in negatives, positives, and zeros, so there was no restriction on that domain, so negative infinity to positive infinity. And then for our range, dealing with our y values, we'll notice that all of my y values ended up being positive numbers, but it couldn't be anything that was 0 or smaller. So because my horizontal asymptote is at 0, that's where it's going to start with a parenthesis, and then we're heading up towards positive numbers. Okay. All right, so there is all of my information for that. All right, so in the past, we've talked about graphs that have transformed based off of different transformations. So we've got vertical translation, horizontal, reflection, stretching and shrinking for both vertical and horizontal. So we're going to be practicing a lot more of these types of graphs tomorrow, but I do want to point out that what we did with transformations last semester is the same idea for these types of graphs. So notice that when we're talking vertical translation, we're talking about moving up and down. And notice that that deals with us adding and subtracting a number that is not a part of the base. Okay, C is not a part of B being raised to the power of X. So it's going to be then C, if it's positive, you are shifting up. If C is negative, then you're shifting down. When you have horizontal translations, that means that your C value is a part of your function. And so anytime a number was a part or in with X, remember we were thinking about going in the opposite direction. So if I see X plus C as an exponent, then we're really thinking about moving to the left. While if it's X minus C for an exponent, we're thinking about moving to the right. So remember, horizontal translations, we're thinking about moving in the opposite direction. Okay, so don't forget about that. While vertical translation, we move in the same direction. And remember, when I'm saying opposite or same, I'm talking about like the sign that we see. Okay, notice that there's a couple of reflections. When you've got the number out in front of the base, that means it's reflecting over the x-axis. While if it is a part of the x in my exponent, then it's reflecting over the y-axis. Then we've got our vertical stretching and shrinking, which means that there's a number being multiplied out in front of my base. But when you have a horizontal stretch or shrink, that's when you're multiplying in the x with the exponent. Okay, so like I said, we're going to practice a lot more actually graphing these types of transformations tomorrow. But I do want to get us once again thinking about the different transformations. So I'm going to have us look at some matching here. So I've got 5 different graphs, and then I've got 5 different functions. We're going to match the correct function with the correct graph. Okay, so if I look at f of x, so small, lowercase f of x equals 4 to the power of x, think about like a couple of the main like numbers if I was to create a table, like obviously 0 would be a good number to plug in. When I plug in 0, anything raised to the power of 0 is 1. So I know that the ordered pair 0, 1 is on that graph. Another easy point to plot would be if I put in 1 for my exponent. 4 to the first power would be 4. So if you take a look at your different graphs, notice that 0, 1 is a point on graph A, as well as 1, 4 being a point on graph A. So it looks like A is going to be that lowercase f of x. Okay. So notice that then my lowercase g of x function, it has the same base. So I know that I want to have that shape that we have in graph A. However, if I'm looking at my exponent it looks like we're dealing with a horizontal movement, okay? Because remember, horizontal because my 3 is with my exponent x. So remember, horizontal movement, we think about moving in the opposite direction. So because I see x plus 3, that means that those points that I have in graph A, I want to move those 3 to the left, and that's going to get me this graph. So notice that if I have 0, 1, and I move it 3 to the left, that would then be negative 3, 1. Notice that negative 3, 1 is a point that's on this graph over here at C. Up here at 1, 4, if I move it 3 to the left, that's going to be negative 2, 4. And notice that that's that point right here. So it looks like graph C is going to match the lowercase g of x function. Notice that the lowercase h of x function has negative 3, but it is outside of my original f to the, 4 to the power of x. So that means that that negative 3 is a vertical transformation. And remember, when it's vertical, the sign that I have is what I want to keep. So notice that means that if I go back to graph A with my original 4 to the power of x, I want to take those points and I want to move them down 3. So from 0, 1, if I move it down 1, 2, 3, I want to be at 0, negative 2. And notice that I see 0, negative 2 right here at graph E. If I have 1, 4 and I move it down 1, 2, 3, I'm at the ordered pair 1, 1, which is also on that graph E. So it looks like at E, we want that h of x function. Okay, and then hopefully that makes sense. They're all going in the same direction as far as they're starting low and they're going high as we move to the right. Notice that B and D are graphs that don't look like A, C, and E as far as the direction goes. And that's because these last two functions are dealing with the reflections. Remember, when I have a number that is outside, the negative is outside of the base, that means that we are reflecting over the x-axis. Okay, so that f of x function, if it's reflecting over the x-axis, looking at A, notice how my graph is above the x-axis, which means then D, it's below it. So that's where this capital F of x is going to go. And then hopefully that makes sense because then the capital G of x, because I've got the reflection dealing with the exponent, that means it reflects over the y. So I want to flip it around. If it's going from low to high on graph A, I want to go from high to low, and that happens to be graph B. So this is the capital G of x. And so there are all of my matching graphs. Okay, so that's us evaluating exponential functions. We're starting to graph exponential functions. Like I said, we'll do more with the transformations tomorrow. And then we are going to evaluate functions with the base of e. So we're starting to get used to where that is located on the calculator. We'll do a lot more with that later on in a different section.